Why do most furniture makers hide the rawness of a slab table with epoxy? I've spent years avoiding this trope because I couldn't resolve the conflict between nature and fabrication. Can I find a point where the organic and the mechanical actually rely on each other? To solve this paradox, I set 3 rules for the build. 1. Zero epoxy. The slab is raw data, irregularities are features. 2. Holistic materiality. 2 geometries, 1 source. 3. Mechanical honesty. Every joint must be a working connection. Most slab builds flood the wood in epoxy and then flatten the material to the point where it becomes sterile, almost like a piece of plastic. I started by prying out the dead wood, all the decay. Every void, every inclusion, every piece of rot is a data point. I am essentially performing site preparation before the real work begins. There was a massive crack on one end. Rather than drown it in epoxy and pretend it never existed, I wanted the repair to be part of the design language, so I routed in a spline to hold it together. The maker in me wants to hide the flaw, the architect in me wants to frame it. The best parts of my work usually happen when those 2 versions of myself start fighting. With the top sorted, the base had to be the absolute antithesis of the slab. My goal was a holistic materiality. Everything is oak, the same tree, 2 entirely different geometries. Now some might look at the burr oak with its aggressive edge and argue it's too wild to pair with such a geometric base. But in architecture you don't choose the site, you respond to it. If the design can successfully reconcile this specific piece of timber with this specific geometry, the logic holds. If it can't, the design is a failure. I returned to a through-tenon detail I'd struggled with in previous builds. Screwing on some temporary end pieces meant I had a reference surface to keep the dowel orientation consistent and measurable. The plan for the joinery was simple: lower the legs onto the router. In theory it was perfect. In reality, it felt inherently wrong. It's the kind of moment in a build where you have a binary choice: ignore your instincts and risk a catastrophic failure, or stop. The usual me might have pushed through, but that's how you get sloppy, unsafe joinery. I stepped back. I tried to learn from previous mistakes. So I built a new jig, a lock-in system for the drill press. By shifting the leg along a measured spacer, I could hog out the material with precision. This is the difference between making and designing. I've realized that the precision of your process directly dictates the quality of the narrative. If the joinery feels soft or loose, the project feels amateur. I needed these connections to be mechanical, tight, and most importantly, repeatable. In architecture, if you can't replicate a detail across the whole building, the logic of the design fails. I applied that same rigor here. I calculated the shear strength of the oak stretchers and decided on a 15mm dowel diameter. Not just for aesthetics, but to ensure that the base could handle the natural expansion and contraction of the slab above it. It's about managing the structural movement of the wood over the next 50 years. That's the difference between a table that lasts for a video and one that becomes an heirloom. We're in an era of disposable furniture. Do you think we've lost the patience for mechanical design, or are we all just too busy to care? With the physics resolved, it was time to move from the theory of the CAD model to the physical stress of the assembly. The glue-up was a nightmare of angles. I was forcing together dry, tight tolerance joints. It's not elegant, there's a lot of hammering and a lot of stress, but it's the price of a joint that actively holds the structure together. It's a tension-based assembly. The resistance you see here isn't a mistake, it's the result of precision dowel to tenon clearance. The structural load is distributed across all of the parts, so the pieces rely on each other. The result is a zero-play connection. No fasteners, no epoxy, just pure mechanical tension. It's clean, it's repeatable, and more importantly, it's structurally sound. Next, I return to the slab to refine the live edge. By turning this wildness into a feature, we're reinforcing the integrity of the piece. It turns the natural edge into a tectonic detail. And there's something tactile about that. When you look at high-end architecture, you don't hide the material qualities, you celebrate them as the language of the building. Why should a table be any different? Now here is the moment of magic. I wanted to carve a geometric outline into the slab where it overlaps with the leg. It's the point where the natural form is forced to accommodate the engineered geometry. Most people might just see a slab table, but the reason it works, the reason it feels intentional, is because I spent hours wrestling with the base just so this one detail would look effortless. It's the contrast, the wild, burled oak meeting the clinical, sharp line of the oak leg. That's the tectonic hook of the piece. You see, when you touch this table, you're touching an intersection of two different philosophies. This is where the maker and the architect in me collide. The maker wants to rush the cut, the architect demands the perfection of the line. As beautiful and raw as the burr holes appeared, leaving them open created significant dead zones where the surface tension of the table would break down in real-world use. Now, I set a constraint for this build, zero epoxy. I wanted to avoid the plastic, sterile look of a resin-poured table. However, leaving the larger voids meant the table wasn't functionally viable for a living space. So I approached this not as a repair, but as grouting. It's a subtle nod to masonry, ensuring the surface is a singular, continuous plane. It's about legibility. It turns a chaotic, unusable cavity into a resolved architectural detail. I chose Osmo Raw for the base to keep it matte and industrial, and a satin finish for the top to bring out the depth of the grain. This was about balance. The finish shouldn't mask the wood, it should highlight the geometry. I applied the finish in 3 distinct stages, allowing for curing times between them to ensure the wood was fully saturated, but not glossy. I spent a long time debating whether to leave the smaller burr holes open. Initially it felt authentic, but ultimately it felt like an unfinished thought. I spent the better part of a day filling them with a wax stick. It looked like a total disaster during the process, the kind of moment where you wonder if you've ruined the whole piece. I've banned epoxy from my shop, but I know many of you live by it. Is zero epoxy a design evolution, or am I just making my life harder for no reason? Anyway, after a bit of sanding and another coat of finish, the piece really all came together. Wood is a living material, it's chaotic and unpredictable. Making this table taught me that my work isn't about choosing between the natural or the engineered, it's about the collision of both. A paradox that only resolves through design and making.